All right, questions 8 through 10 on the Unit 10 example set. This is Mr. Kingsbury. Once again, we are going to be writing some equations. Number 8 says the cost of printing cookbooks is $2.59 per book, plus a one-time setup fee of $273. All taxes are included. Write a function that models A of X, the average cost per book of printing X books. So this is a cost per unit situation. We're going to put A of X on the one side here instead of Y. And we know with cost per unit, we're always going to just divide by X. And then the question is what goes on top. So we need to take our one-time fee or our flat fee, which in this case is $273. And we'll add that to the unit fee. It's $2.59 per book. So we'll do $2.59 times X. So it's going to look like this. $273 plus 2.59X, all divided by X, equals A of X. Then we got question 9. Kiki walks to the grocery store that's 5 miles away. Her walking rate on the way back was 0.80 or 0.8%, if you or 0.8 of her walking rate on the way to the store because she was carrying a bag of groceries. And it took Kiki 3 hours to make the round trip. So we're going to write an equation that could be used to determine the walking rate R on the way to the store in miles per hour. This is a distance, rate, and time problem. It's talking about distance, it's giving us time, and it talks about how the rate is different going there and coming back. So we need to set up some kind of equation to that effect. It says that the round trip took 3 hours. That's the total time for the first part, or the time to the store, plus the time coming back is going to equal our total time. In this case, 3 hours is our total time. Now we know going to the grocery store, it's 5 miles. So the grocery store is 5 miles away from her house, and she's going to walk back to her house. So it's going to be another 5 miles. It's going to be the same distance, in both sections of the trip. And we know that her rate walking there is going to be R, right? R is her walking rate on the way to the store. So we'll put that there. What's different is on her way back, her rate was 0.8 of her walking rate. So we would take R and we would multiply it by 0.8. That's going to give us our equation. Lastly, we got number 10. Using a forklift, Rico can unload a boxcar in 70 minutes. It takes long to complete the same task. Write an equation that shows in minutes M how long it will take them to unload the boxcar if they work together. This is a work problem. So we will be adding two fractions, and it will equal 1. Always equals 1. The bottom of the fractions will be their individual times. We know that Rico can unload this thing in 70 minutes. And it says that Ashki takes twice as long. Well, 2 times 70 is 140. So that's going to go on the bottom of each of those fractions. What goes on the top is the time it would take them to do this together. And we don't know what that is. We know that it's going to be represented by M. So we'll just put an M on the top. And there you go.